Hi everyone, we are now ready for Module 18, which is about conditional probability. After watching this video, you are expected to solve problems involving conditional probability. Let's have some practice first for you to have an idea of what conditional probability is all about. I would like you to solve each of the following problems and write the answer on the space provided. For number 1, number 2, number 3, number 4, and number 5. You can always pause and play this video if you need more time in answering the problem. Now let's check if your answer is correct. For numbers 1 and 2, for numbers 3 to 5. Did you get a perfect score? It's okay if not, but you have to listen to the discussion of conditional probability. Let's have a recap first. I would like you to identify if the given problem is independent or dependent. Then answer. Probability that none of the 3 students passed the periodic exam. Number 2, at least one of them passed the exam. Let's check if your answer is correct. This is an example of independent event. And to answer number 1, we simply multiply 0.3 by 0.3 by 0.3, which is equal to 0.027. And to answer number 2, just get the complement of number 1, which is equal to 0.973. Did you get the perfect score? I hope so. Decided die. What is the probability of getting a 3 given that you know that the number is odd? How are you going to solve this problem? For the solution, we let A be the event of getting 3. So A is equal to the set containing the element 3. B be the event that the number is odd. So B is equal to the set with an elements 1, 3, 5, because these are the odd numbers in a six-sided die. We also need the intersection of the two events, which is equal to 3. 3 is the element which is common to events A and B. And then we can get the probability of the intersection, which is equal to 1 over 6. Why 1 over 6? Because we only have one element in the intersection over the 6 elements in the sample space. We also need the probability of B, which is 3 over 6, because we have 3 elements in B, over the 6 elements in the sample space. And then we divide them. 1 over 6 divided by 3 over 6, we'll have 1 over 3. But how did we arrive in this answer? Or where did we get this formula? This problem here is an example of conditional probability. But what is a conditional probability? Conditional probability of an event A is the probability that the event will happen given the knowledge that an event B has already happened. And for that, we need this formula. Probability of A given B is equal to probability of A and B divided by probability of B. What is the formula again? We were given the two events. B has already happened. A will happen. And it is equal to their intersection divided by the probability of the event that already happened. Please take note of that. And let's make use of this formula in the following examples. Number 1. The probability that Arnell studies and passes his math test is 0.45. If the probability that he studies 0.80, what is the probability that he passes the math test given that he has studied? Let us identify the two events. Events are studies, passes. Studying, passing. And there is a word and. Therefore, there is an intersection between the two events. And that is what we need to solve the problem. So we let B be the event that he studies, so the probability of B is equal to 0.8, which is given. The probability of A and B is equal to 0.45, which is also given in the problem. So what we need to do now is to substitute that in the given formula. So 0.45 divided by 0.80 is equal to 0.562, or simply 9/16. Were you able to follow? That's great. Now let's continue with example number 2. 100 students go to a leadership camp. After grouping, the number of boys and girls in each group are as follows. We have here a two-way table containing the boys and the girls and the different groups. If a student is chosen at random from these 100 students to give a self-introduction, find the probability that the student from the blue group is chosen, given that the student is a boy. So for our solution, we need the two events. And these are the blue group and the boy. And since we have a two-way table, we can simply identify their intersection. Therefore, let B be the event if the student is a boy. So the probability of B is equal to 60/100. But where did we get 60? It's the number of boys in different groups. We have 14 plus 18 plus 15 plus 13 is equal to 60 over the 100 students, which is the sample space. The probability of A and B is equal to 18/100. Where did we get 18/100? The intersection of boy and blue, and that is 18/100 of students is the sample space. We can now divide using the formula. By substitution, 18/100 divided by 60/100 is equal to 18/16, which is simply 3/10. Were you able to follow? I hope so. Let's proceed to example number 3. A fair die is thrown twice. Given that the first throw is an odd number, what is the probability that the sum of the numbers obtained is 7? In this problem, you can identify the events as sum of the numbers obtained is 7, and the first throw is an odd number. So this is event A, the sum of the numbers obtained is 7, and event B, the first throw is an odd number. Can we identify the intersection out of this? If not, then I will suggest that we let A be the event if the sum of the numbers obtained is 7, and let us identify the different elements contained in set A. And these are 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 2. Because these numbers here sum up to 7. Can you think of another set which has a sum of 7? No more. So we only have 6 elements in A. How about B? B the event if the first row is an odd number. So for as long as the first row is an odd number, that belongs to set B. And these are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Because the first number is odd. Followed by 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 6. And 5, 1 up to 5, 6. And if you count them all, probability of B is equal to 18/36. We have 6 starting with 1, 6 starting with 3, and 6 starting with 5 for a total of 18 out of 36, which is the number of sample space. So after identifying the elements in A and B, we can now identify their intersection, which is 1, 6, common to A and B, 5, 2, common to A and B, and 3, 4, common to A and B. So we have 3 elements, therefore, the probability of A and B is 3/36. And by substituting in the formula, we'll have 3/36 divided by 18/36 is equal to 3/18, which is equal to 1/6. I hope you were able to follow the discussion. To sum it up, remember that the probability that an event will happen, given that another event has already happened, is called conditional probability. And to solve for that, we are going to use the formula probability of A given B is equal to probability of A and B divided by probability of B, or probability of B given A is equal to the probability of their intersection divided by the probability of B. Whatever the denominator is, that is the event that already happened. And that will be your denominator. Please take note of that. For our valuing, in your journal, I would like you to reflect on this. You are now ready for the post test. Answer each of the following problems and write the answer in the space provided. For number 1, numbers 2 and 3, numbers 4 and 5. Let's check if your answer is correct. For numbers 1 and 2, for numbers 3 to 5. I hope you were able to get a perfect score. Good job! You are now ready for the different activities that I have prepared for you. For our activity 1, for our activity 2, for our activity 3. Let's check your work. Activity 1, activity 2, and activity 3. Thank you for listening. Have a good day. Keep safe, everyone.